What if I told you that Google just built a computer that thinks 13,000 times faster than one of the world's most powerful supercomputers, and it's not even science fiction anymore? Google just announced a massive leap in quantum computing, a moment they're calling the first ever verifiable quantum advantage. In simple terms, their quantum computer has officially done something no classical computer on Earth can match. But how big is this really? Are we talking about curing diseases, building new materials, or cracking global encryption? Let's break down exactly what Google achieved, why it matters, and how it might change the future of computing as we know it. Alright, so let's start from the top. Google has developed a new algorithm, basically a set of instructions for a quantum computer that did something even the best classical supercomputers couldn't replicate. They call it quantum echoes, and it ran on Google's Willow quantum processor. The result? It performed a molecular structure computation 13,000 times faster than one of the fastest classical supercomputers on the planet. Think about that. A problem that could take supercomputers months to solve was completed in minutes, and not just once. It was repeatable and verifiable. That's the key, verifiable. In quantum research, that's a big deal because most past results couldn't be checked or confirmed by classical machines. This time, the math checks out. Anyone with a quantum computer, or even nature itself, can verify it. Michel Devoret, the chief scientist at Google's quantum AI unit, who, by the way, just won the Nobel Prize for Physics, called it a new step toward full-scale quantum computation. Now, here's what makes this especially groundbreaking. The algorithm wasn't just a random test, it was used to model molecules, the building blocks of life, chemistry, and medicine. By simulating how atoms interact inside molecules, this could eventually lead to designing new drugs, superconductors, or even cleaner energy materials right from a quantum chip. But before we get carried away, Google admits real-world applications are still a few years away. Why? Because building a fault-tolerant quantum computer, one that doesn't make constant errors, is insanely hard. Today's quantum chips work with dozens or hundreds of qubits, the quantum version of bits. To handle major real-world problems like full drug discovery or weather modeling, we'd need millions of qubits. And the kicker? These qubits are super fragile. They have to be kept at temperatures colder than deep space and completely isolated from electromagnetic noise. That's like trying to hold a soap bubble in a hurricane. So, here's the catch. Yes, Google has achieved what scientists call quantum advantage, where a quantum computer beats a classical one at a specific task. But the question is, does it actually matter yet? Winfried Hensinger from the University of Sussex put it perfectly. He said, "It's important to understand that the task Google achieved is not quite as revolutionary as the world-changing applications people imagine. In other words, it's still a science milestone, not an industrial revolution. At least, not yet." To give you perspective, the molecules Google modeled were tiny, just 15 and 28 atoms in size. Still, it's the precision and the verifiability that's new here. They even cross-checked the results using nuclear magnetic resonance, the same tech used in MRI scanners, and found information that NMR couldn't reveal on its own. That's a big sign that quantum computing is no longer just theoretical. It's starting to produce real, measurable science. Now let's unpack why this matters beyond just quantum physics. Google's Vice President of Engineering, Hartmut Neven, said something interesting. He believes real-world quantum applications, things that classical computers simply can't do, could arrive within 5 years. And there's another angle, AI. Google argues that quantum computers won't just make AI faster, they'll make it smarter. Why? Because quantum machines can generate unique types of data, patterns and probabilities that classical computers simply can't. That kind of data could feed into AI models and unlock entirely new kinds of intelligence. So, imagine this. AI models trained not just on human-generated data, but on quantum-generated data. That could lead to better reasoning, more accurate predictions, or even entirely new ways of discovering scientific truths. Of course, not everyone's cheering. Cybersecurity experts are already warning that powerful quantum computers could crack traditional encryption. That means all our digital locks, banking, military, personal, could become useless if we don't develop quantum-proof cryptography fast enough. In other words, the same technology that can cure diseases might also break the internet. So yeah, it's true. Google's quantum computer just did something supercomputers couldn't. It's not the end of the story, it's the start of the quantum era. The next 5 years will decide if we can go from one verified algorithm to solving real-world problems, from medicine to materials, energy to intelligence itself. And when that happens, it won't just be a tech revolution, it will be a human one. Subscribe for more such videos and click on bell icon to get updated.